All right. Hello, 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 and welcome to the August edition of the virtual Kansas City SQL Server user group. Tonight we have Deborah Melkin talking with us about mastering dynamic SQL. My own personal nemesis, dynamic SQL, not Deborah, obviously. Deborah and I are tight, and she can tell you. I've been begging to get her to speak for our group for a hot minute because she's a hot commodity, and we are so honored to have you here tonight, Deborah. Thank you. We will be having Q&A throughout the presentation. Deborah will be pausing at specific times to ask for questions. Just a note, the session is recorded and will be uploaded to our YouTube channel in the next few days. And with that, I'm going to let you take it away, Deborah.
All right. Well, thank you so much for having me. I'm so glad we were able to figure out a time because, yeah, as she said, we've been going back and forth trying to figure out when I can come and present for y'all. So I'm really excited that I finally get to do this because this is a topic that's nearer and dearer to my heart than it probably should be because, who loves dynamic SQL? Um, a- as Christy said, I will be taking questions. I will be pausing at points, so those will be good points for questions. But if something pops up at any point, feel free to put it in chat. If I'm looking over this way, it's because that's where my second monitor is, and that's where I've got Teams up, and I have the chat window open, so I can see any questions that y'all post in here, and I'll try to keep an eye on it. But again, I will have points where I'll probably want to stop, breathe, take a drink, something, the usual stuff. So with that, let's dive right in. So for those of you who don't know me, my name is Deborah Melkin. I've been working with the data platform for well over 20 years. I try not to do the math. I mainly work with SQL Server, but I've done work with a couple other different database systems, just enough so I could do damage. I am mainly a transactional database person, but I've done stuff with data marts and warehouses, just enough so I can do some damage. I am a co-leader of the data platform WIT user group. It's really exciting. We've had a couple changes over the summer, so I'm very excited to be being a part of that. We have a lot of fun stuff that's coming up, so we hope you all will join us for that. I'm also the co-founder of Witspiration along with Tracy Bogiano, and essentially it is a mostly women in tech, mostly focused towards the data platform, but it's a mentoring circle and a group of mentoring circles, plural networking, and it's really, I love mentoring people. I love being a part of that. So it's really, women in tech is definitely something I'm very passionate about and happy to be stepping forward in the community with that. I'm also a Redgate Community Ambassador, and I'm very honored and humbled. I can't speak this evening. I'm not sure what's going on. Honored and humbled to be a Microsoft MVP of the data platform. For me, what it means is I love going around talking about tech. I love talking about databases and SQL Server in particular. And I'm very honored to be in a group of people who do so much more amazing things than I do. So very honored about that. But with all of that, that's not the important stuff to remember about me. This, this is the important stuff. I'm a longtime member of my choir's alto section. I say I pick up bluegrass jams regularly, but I've had trouble getting to them. But whenever possible, I try to go to bluegrass jams. They're a lot of fun. I've been learning guitar. I've been neglecting my mandolin. It's here. I probably still remember a couple chords. I'm a musical theater geek. Some of you who just heard that I'm going to see Kristen Chenoweth in a pre-Broadway Stephen Schwartz show, brand new, super excited for Thursday for many reasons. And then when none of that's going on, my husband, some of y'all know because he's very active in the community as well, Andy Yoon, he and I like to take pictures of our dogs doing geeky things like looking at a computer, probably solving problems better than we can. So this is the important stuff to know about me. But that's probably not why you're here. You want to talk about dynamic SQL. So let's get down to the root of what dynamic SQL is. It's a pretty simple question with a pretty simple answer. Dynamic SQL are SQL statements that are created ad hoc and then executed. And at the core of it, that's all it is. So now that you know everything, well, okay, yeah, it gets a little more complex than that. So with that, let's kind of get a little more into dynamic SQL and some of those things that give it really bad reputation because dynamic SQL really does have a bad reputation. Some of it is actually earned, but some of it is just, it's really hard to work with. And there are a lot of nuances to kind of pay attention to as you work with it. So that's kind of what we'll talk about. So first, we're going to talk about use cases. When would you want to use dynamic SQL? It is not appropriate for every case, but there are some where it actually really does make a lot of sense and can be super helpful. Security. I'm not going to harp on this too much, but I'm going to harp on it because this is where people don't like dynamic SQL at all. We're going to go over syntax. Most of the stuff I'm going to talk about, but we'll spend a lot of time in the demos. And then we'll kind of talk about different tips and tricks that I find really helpful for using dynamic SQL. I've had a lot of projects over the past year where I feel like I was just writing dynamic SQL by default. Like that's all I was doing. I was taking everything, making it dynamic SQL, and the entire project I was working on is run on dynamic SQL. It's kind of crazy, but I had a lot of good lessons that I've learned. And a lot of these tips and tricks make me say, it's not for every case, but if you're going to use it, these are really useful things to know. All right, let's start with our use cases. When were good times we want to use it? Well, I would say catch-all queries, end-user customized queries, variables for things like servers, databases, or objects, and then delay parsing of queries. So what do I mean by catch-all queries? That's that single query, that kitchen sink query that tries to account for all of the options available. You know, you've seen those. You've got that screen with 50 different options for search, and you have that single statement that's like where the column equals the variable or the variable is null, and column equals this other variable or that variable is null. And this right here is a very tame version of stuff that I've seen in the field. My rule of thumb is if you find it hard to read, so is SQL Server. And if SQL Server finds it hard to read, you're probably not going to have a well-performing query. These sort of things, especially these catch-all queries, confuse the optimizer, and so you don't get good query performance. But using dynamic SQL, you can probably mold the query into something that makes a lot more sense. End user customized queries. This was a real world example from a previous job. The application has screens that display data based on what clients choose. So if you've got 200 clients, those 200 clients may want to see different things on the same screen. But the way those interact, you're calling to things from different tables. You may not need information from certain tables to pull things together. It can be very confusing when you put it all together. So for example, we're going to use a car dealership database for our demos today. An example for using that would be a dealership A wants to see a VIN number, they want the true cost of the car, they want an invoice price. Dealership B wants VIN, so that matches, the base model name, package name, MSRP. All of these things are not on the same table. They are using different tables. I don't want to have to do joins across everything to pull back different things. And even my column list is different. I don't want to pull back everything to the application because that's too much. But I can use customized queries to pull back that information using dynamic SQL. Variables for static information. So this is those cases where we need the same query, but we need it run against maybe different databases or different tables. This also helps us build things like, I want to pull different columns from different tables and create that join from the example we saw before. Oftentimes we're going to have things that we need to run across all the databases in our instance because we need to find information as part of our maintenance plans. You can't write a statement like select from, have a variable for your database name, and then your column, and then your table. That's not allowed. But you can use something like dynamic SQL, this example below, where you can make that, take that variable, create your statement, and then run it against everything you need to on your instance. This last one is called delay parsing. So when you run a SQL statement, the first thing that it does is it parses your statement. With delayed parsing, when it parses, it's going to parse saying, I'm going to run this statement dynamically. It's not putting that statement together and checking it at that time, it will check it when it finally executes things. So what this does is it moves that parsing to someplace else so we can allow for better error handling. It allows us to isolate statements. So when we do things like upgrades, that's the common time when I'll want to delay parsing. It allows me to bypass errors and do checks that I wouldn't be able to otherwise. For example, I'm going to run a statement where I'm selecting from 3 columns. I drop the column. I go back to run the statement again. I have a problem because this column no longer exists. And I've done that before for upgrades. I have the same script for upgrades and it's run multiple times. To prevent errors, I can use dynamic SQL to make sure I bypass that error because I'm not looking to see that this drop column or this column is there. I can bypass it because I'm going to say, hey, I'm going to run this statement instead. We'll go through that when you do the demos. It's a little harder to explain. Now we've talked a couple use cases. The next things are security and vulnerabilities, because this is where dynamic SQL gets really scary. This is why people don't like dynamic SQL, because little Bobby tables comes into play. We all know this comic, little Bobby tables. Did you really name your son Robert Drop Tables? Students? Sanitizing database inputs. This is one of the big problems with dynamic SQL, and this is one of those security problems. We need to make sure that whenever you write dynamic SQL, you write it in a way so someone doesn't do something like throw a drop table statement in there and you have no clue that it's there, or do something else to get information or create errors that's going to display information that we don't want an end user to know, or especially someone who's a threat actor. You know, we want to make sure we're securing our databases, but still allow that flexibility. This is one of the top reasons why people don't like dynamic SQL, because if you don't write it correctly, you allow for SQL injection. We want none of that. We'll talk about different ways to combat it, but the biggest thing is really make sure when you put dynamic SQL together, you're not allowing this sort of thing to happen, and you're not putting yourself in a situation where this can happen. All right. Syntax. This is almost a simple part because there's pretty much 3 basic ways you're going to write dynamic SQL. The first is exec your variable, which or whatever your dynamic SQL statement happens to be. Or you can also say execute. I tend to write exec. It's very simple. It's very straightforward. The second one is exec sp execute SQL. This is a system store procedure. I believe it's actually in the master database, so you could also write exec master. I believe it is in the DBO schema and SP execute SQL. This is really cool because this is a really flexible way of getting your data or getting your dynamic SQL in and being able to execute it. Partly because it allows for parameters. So you can pass parameters into your statement and you can pass parameters out of your statement. It's also considered a lot more secure than something like exec at SQL, but it's a really good way to write dynamic SQL. I, by default, almost always use this. There are cases where I don't, but most of the time I'm going to use SP execute SQL. The last one, it's not documented, it's not officially supported, but it's SPMS for each database or each DB statement variable. What this is going to do is this is going to run against all your databases on an instance. We have a lot of admin things that we do where we need something to run across all of our databases. This is a way to do it. There's actually an extension store procedure or a wrapper store proc for this. I have references to later. Aaron Bertrand, I believe, is the person who pulled that together. It has a lot more flexibility that it adds on this, but it's essentially based on that concept. Of the 3, which one should you use? It's really recommended that you use SP execute SQL. I have a great blog post at the end by Tara Kaiser, and she really gets into why this is what you want to do. It's just considered more secure, but again, the way that you could do it, the more it has a lot of flexibility to it. It's really the preferred way of doing it. And I think you'll kind of see it as we go through some of the demos and we talk through it. So we've hit the point where I could continue to talk about it, or we can actually go into our demos. So let's switch over to that. All right. So any questions before we dive right in? And if you have any, feel free to put them in the chat along the way. I'll try to keep an eye on that as we go. So as I
I don't see
said,
any.
all right, thank you. As I said, we're going to use this auto dealership demo database, and I'm going to have my reminder here to turn on my execution plans. And I have a note that I want to explain. You'll see me use nvarchar max a lot for my variable, a lot. I probably shouldn't, but in some ways I'm lazy and I'll admit that. But what happens is we need to create our statements. And I've written some really, really ugly long SQL statements in dynamic SQL. And in order to compose those SQL statements, I can't limit myself. So there are a couple reasons. SP executes SQL, the store proc, that parameter is Unicode. So you have to convert anything that you pass to it to nvarchar anyway. As I said, half the time I don't know the size of the statement that's going to be created. And I've written some really, really, really long statements where, did you know that the print messages has a limit of 4,000 characters? Ask me how I know, because I'm trying to print out the statement that I've created and it's just too long for a print. But the longest thing we can pass in is 2 gigs of data, which happens to be nvarchar max. So for me, I know I'm going to hit that limit if I'm doing based on past projects. I'm pretty sure I'm going to hit limits, so I tend to just stick with nvarchar max. Again, it's a parameter that I'm passing in. I'm not saving it as a table, so I feel like I'm justifying it. If I know something's going to be shorter, sure, I can use that, but I hit that limit way too often that it's just easier for me to go with the max size I can fit within a dynamic SQL statement. So now that I've justified myself or over justified myself, let's take some examples of things. So we talked about exec versus SP execute SQL. Hopefully this is large enough for you to read. If you need me to zoom in, let me know and I will do that as well. So the first thing I'm doing is I'm going to use a variable just because I can use that same statement and pass it across all my different examples. So declare my SQL statement. I'm going to select initial test, and then I'm going to run. And we can see it ran. I don't have I'm execution plan because it's just a static value. So let's do something that generates query plans. So now I'm going to select the top 10 from my inventory table. I'm going to pass it to my exec, SP execute SQL. See, I get 10 records back, but I'm more interested right now in my execution plan. And we can see that the statement that is executed comes up here. So again, top 10 from inventory, select top 10. This is going to be the same query plan because it's the same exact statement. There's nothing about this that would cause the query plans to be different. But it's interesting to note that now I can see what's actually being run, where before I just know I'm doing this exec statement. One thing I want to show you quickly, may have the note later, but I'm going to do this now, is I want to show you what it means by display estimated execution plan. So now I'm going to run this or just get my query plans for the statements that I'm about to run. This is what I actually ran. If I wanted to see what I was going to run before I run it, I get something very different. And this is where we'll see later why it matters for things like delayed parsing. Because what SQL Server thinks it's going to run isn't what it's actually running. It thinks it's running this exec at SQL statement, so it's just an execute string. And here it's running that store proc, but it's going to do whatever that proc does behind the scenes that we don't get to see. Oh, it's sys sp execute SQL. So if you're curious about the schema that it's in, but it's all in the master database. But again, this is not what it's actually running, but this is what it thinks it's going to run when I parse my statement or I say, hey, get me the estimated statement. It's not the actual thing it runs at runtime as we saw. That'll come into play later. So now let's start making things where it's a little more dynamic. What if I don't want it to run just for inventory? I may want it to run for something else. But let's start with inventory. So I'm going to declare my dynamic SQL variable, and now I'm going to do one for table. I'm not even going to bother trying to run this statement because it doesn't run, because you can't say from whatever this variable is. It actually has to be an object. So there are a couple ways you can write this. If I used exec, I could write it just like this: select top 10 from plus my variable. I can't really do that if I'm going to use SP execute SQL. I have to pass everything in as a single complete statement, my environment. So what I'm going to do, just so I can use the same thing and show you all how it looks, I'm setting my SQL variable to be select top 10% from, adding this, adding my object name. I'm going to execute both counts. And it helps if I do my variables with that. And there we go. And if I go to my execution plan, it's that select top 10 from inventory. So it put it together, ran the statement as it needed to be run. Pretty simple. But now we're getting into things where we want to start worrying about security. Because right now, what sort of checks do I have to make sure that this at table is only at table? Because inventory is only 10 characters long. I'm putting in sysname. Sysname is nvarchar 128 because that's the longest that you can have for a name. 128, I got about over 100 characters I can play with. I could do bad things. We don't want bad things to happen. So let's prevent another little Bobby tables issue. So for example, I'm going to select my statement, table, inventory, select Kansas City, we have a problem, as my injection statement. And I'm going to run all of this together. And look, I have an extra statement. If I wasn't careful, I could do things like drop table, or take a backup, or do delete from table or something like that. See what sort of fun things I could do to throw things off. So how do we prevent this sort of thing from occurring? I think a lot about this is with the objects. But again, it depends on where we put things and how we create our tables, that we can kind of think of ways to prevent this. When I'm doing objects, one of the obvious things is to use square brackets, for example, on either side. So if I have my statement select from square bracket object, everything within that should be a single object. So what happens if I throw it in here? Trying to break things. Nope, we still have a problem because it's the way it's putting it together. Inventory, it's still figuring out that I'm piecing this together as a string. It hasn't figured out that I want this whole at table, this whole variable, to be treated as a table name. This is what quote name is for. And this is one of those things where I'm like, there's some things that I've done in the past. I'm like, yeah, I really needed a lot more quote name. But I've tried a lot of way to break it with quote name. But if I take the same variable I used here, copied it directly here, use quote name, it can't figure it out because it's taking everything all together and it's treating that entire thing as a quote. So spaces, it still thinks it's part of a quote, or it thinks it's part of the table name, because when you use square brackets, you can actually do bad things like put spaces in your object names. So this is assuming all of this is a single object name when I put it in quote name. I remember when I was first creating this demo, I was trying different ways to break it. I couldn't. It is like whatever combination, I wasn't finding it. So I felt like quote name is really a secure way, especially when you're doing objects, select from objects, as a way to kind of confirm and prevent someone from putting things in their parameter, in that variable, that shouldn't be in there. But this also gets into when you're going to pass those things in and how you're running it and where those values are coming from. You really want to be careful of how you're setting those up, how your either developers are passing those in. If you're using it yourself, What are you doing to create the different things that need those variables so you can really make sure that you're passing in good values and you're not allowing extraneous information to pass in that could cause you to, like, I don't know, drop your database and things like that. Add users that shouldn't be there. But quote name is a very secure, especially anything having to do with objects. So your database name, your schema name, your table names, your column names. They are a pain to deal with when you start reading your statements and such, but you feel a lot more secure in terms of, I've got these dynamic things being passed in here. I know I'm going to get a legitimate object. And if it's not, it's going to error out and I don't have to deal with it. Or I can prevent something from bad from happening. So it's a quick way of doing it, but you really have to think about what are you doing to secure your statements. All right. So this next bit was a fun one because we don't think about the relationship of our dynamic SQL to the batch that it's running in. Take a quick drink. So I'm going to do a couple things. I'm going to select the SPID so we can see what session ID we're in now. I'm going to run sp-execute SQL, get my SPID information. I'm going to do the same thing, but from an exec statement. And just for fun, I'm going to show it using XP command shell. So because this is really interesting things, and it's really important to understand how everything works. I'm going to zoom over here a little bit. We notice my batch is 58. My dynamic SQLs are also 58. These are all the same session ID. Now, if we go to XP command shell, it's 83. So XP command shell, it's a completely and utterly different session from the one we're working within. This kind of opens up some behavior for how we can use dynamic SQL and what we can put inside our dynamic SQL and really thinking about how it's working overall with different things. So temp tables is really a great way to show this. And this is actually where I started thinking about, oh, I had a lightning bolt in terms of how all of this stuff works together. So I'm just going to make sure this doesn't exist. I'm going to create my temp table. It's a very simple temp table, an ID and a sample value. Normally, how I think of doing statements with dynamic SQL when I need to put that information into a temp table, I declare my create my statement, and then I'm going to insert into my temp table what I've just executed. And this works. We can see here my one record that got inserted. It's exactly what I expect it to find. But knowing that this is executing in the same session that I'm in right now, what do we know about things like local temp tables? Those are in the same session. As long as that session's open, it's accessible, which means I could do something like a dynamic select statement, insert into my temp table, and add that as part of my dynamic statement. And I have that inserted without error because it's part of the same session. I can see what's in that temp table. I have access to that temp table because I'm still part of that same session. That was a really cool one for me to find and actually helped me solve some problems. So what about parameters and especially local variables? All right, so I'm going to start with using just exec. So now we can start really see some of the difference of the way we write dynamic SQL and some of the advantages and disadvantages of things as well. I'm going to look for inventory where I have a base model of a particular value. Now, I'm in the same session, so I could see it from a temp table, but I see my local variable. I'm running this as a batch. I should be able to have access to all of the variables, right? Except I don't. Because when you do dynamic SQL, while it's part of the same session, what's working inside here, it's kind of a little bit of a black box. It's part of the greater one, but it's not quite part of that same batch that the session is in. So what we have to do is we have to write things a little bit differently. So again, my statement, my variable, if I'm using exec, I have to write it in where I have to deal with things like conversion. So I have to take things and make it part of my statement. So this means if I were to use a string value or a date time, I have to convert those and put the extra single quotes to make all those things work in dynamic SQL. That's a really big pain. But with SP execute SQL, I can actually pass in a variable. I can show here that this is the variable. I'm going to call it the same thing here, and then I can pass in my variable. So now we can start seeing some of the difference between the two and what comes out of it. So I go through and I'm running for the base model. We can see the base model is the same. But when I look at the execution plan, we can start seeing where the difference is. For my exec statement, because I'm passing the way I'm creating it, my 58 here, this is a constant. Here, it's a parameter. So now we start thinking about what it means for dynamic SQL and what we're doing for the queries that we're creating and things like query plan float. For example, if I call this often and I'm constantly having to send in constants, if I'm doing 1, then 2, then 3, I'm going to have multiple versions of the same statement, but they're all tied to the specific ID. This one gets reused. So now I've created a parameterized statement that anytime I execute it, it's going to look and it's going to try to find this plan first, and I don't have query plan float. Now, there are cases where you may want to do that. Maybe you're using it because you want to prevent parameter sniffing situations because everything's so disparate. But you want to know what you're trying to do and what those options are. So whether you're creating a variable or passing in the constant, you'll want to think about your use case for that. But the other thing is what happens when you have to deal with multiple parameters. So I want to base model ID and your package ID. So again, it's a different way of creating your statement versus exec versus SP execute SQL. For example, I got to convert all of these and put those together to make it work. Here, my statement can include the variables and I can pass both variables in. These do need to go in the order, otherwise you're passing in the wrong variable or the wrong value for each variable. But with these are the same, it's easy to say base model ID, package ID, package ID. We can run. We can look at the execution plan. We can see what was done. Again, we have set values here, and we have our parameters that are passed in here. Just to prove a point, the parameters passed to the query, they don't have to match the name that you have inside. Think of it this way, SP execute SQL, it's a stored procedure. This first thing, what it's doing is we're creating a on-the-fly stored procedure almost, because these are these right here, these are the variables that go with your statement inside this ad hoc stored proc. And these are the parameters that you're passing in. So now I'm changing the exec SP execute SQL. I've got two new variables that I'm using. Base model goes to base model. My new package ID goes to package ID. These two match with what's in my statement. And so when I run this, this is going to run just the same as it did before, where it's my statement base model equals at base model, package equals at package, because these are the ones that I'm looking for in my statement. But it does mean that whatever you're passing to your dynamic SQL, these variable names don't have to match exactly. You just need them in the correct order, otherwise you're passing the wrong variables to the wrong parameter. Because again, here's one I have the example where the order still matters, where if I do package and switch those up, well, now I have different things because now I pass the base model of 4 and 58, and that's not the values that I wanted to pass in. So again, it's just knowing the order that you're passing everything into. It needs to match what you have what you're setting up on the inside of your dynamic SQL. The last piece I want to show with parameters is output parameters. I want to pass in base model and I want to get a total count and I want to be able to pull that information out. I can't do that with my exec statement. I'm not even going to try because I know this doesn't work. If I wanted to use exec, I could do something like create a table variable or a temp table, and then I'd have to take that value, put it in there, and execute, and then I'm selecting from a table variable or whatever, or temp table. And it works, but that's a table. That's not what I want. I want a variable because I want to use that later. Again, SP execute SQL allows that flexibility. So it's also much cleaner to write, where what I'm declaring, again, these are like I'm declaring my store procedure variables that are going to go to inside my SQL statement that go along with my select statement that I'm creating. Here's the value I'm passing in. Here's the value I'm passing out. And yes, you can have multiple output variables. But we run here, and now I've got my select, and this is just my variable. So now I can take this, I could use it somewhere else in another query without having to select from something else. I don't need all of that. I just need it in a variable. Let's continue with some of our dynamic SQL behavior. What happens if you change the database name inside a statement? All right, so I have a superheroes database. So first thing I'm going to do is I'm going to select my database name where I am now. In my dynamic SQL, I'm going to use my switch database, select my database name, and just to show that I can put, a statement and pass it into SP execute SQL, you can do that. Again, I tend to use a variable, little lazy here. But once I'm done, I'm going to take a look at what my database is outside that statement. Here, auto dealership demo inside superheroes. I didn't switch back, but I'm in my auto dealership demo. This kind of reinforces that idea that even though I'm in the same session and I can access everything that's in my session, like a temp table, everything that's being executed is really in a different context from the everything else that it's running within that batch. So it's a little interesting, but it's one of those caveats that you want to deal with. Sometimes it works in your favor, not always, but you really need to kind of keep that in mind that it's not executing within the context of the session, even though it's part of your session ID. I did want to note there are some things you can't do with dynamic SQL. One of them is use the word go. You can't, it's all of this is a single batch. Everything you're doing within that SP execute SQL is a single batch. You can't do multiple batches. If you do that, it says it has a problem with near the word go. So again, one of those quirky behaviors. So the next thing is, what does all of this mean for transactions? Because we know it's in the same session, so we can do temp tables. It's not the same context, so we can't use local variables. But what does it mean for transactions? What I'm going to do is I'm going to begin a transaction. I'm going to select some data. I'm going to open the transaction, run dbcc open_tran, both in my session and then within my dynamic SQL statement. I'm also going to check the system table because sometimes DBC open_tran doesn't always show me what's going on, especially if it's not taking out any locks. But this system view dmtran active transactions will do that. So I'm going to select from that both in the session, then within my dynamic SQL. And I'm just going to roll everything back at the end. So what do we think it's going to show? So here's my select statement. If I look at messages, we can see things for dbcc open_tran. We do see something because I did something. I did a select. We can see transaction outside, and we see that twice from my dbcc open_tran. So I can see the transaction inside my dynamic SQL statement. And then when we look at our results, we can see messages. We see two sets of messages, transaction outside here, and then over here from inside, we also see our transaction outside. So when you, in the session, I'm in the same database, well, on the same instance even, that transaction plays across. And I can see that within our dynamic SQL. All right, let's play with that a little. I'm going to create my transaction inside the dynamic SQL, run dbcc open trans, see the selects, and go. And then at the end, I think that's when I'm going to roll it back. Wait a minute, I get an error. I mean, I get my insert from here. I see my transaction inside. I may have forgotten to roll that one back. Oh, no, that's the one we did. But I'm getting an error. Why am I getting an error? Transaction count after execute mismatch begin commit statements. So when I was testing this, it took a lot of digging to find out what's going on. This gets into really funky stuff. I took Erlen Summerskog's blog. He has this really in-depth blog. Honestly, it's fantastic, but it goes into depth. And what we're hitting in is nested transactions. And we're dealing with transaction levels with that. What's happening is everything within that exec statement is a nested transaction. You'll see this with triggers as well. You're a nested transaction. It's a transaction within a transaction. I'm going to, in my session, to prove this, I'm going to show you what my outside transaction is and my outside nest level is. Then I'm going to execute that within my dynamic SQL statement. We can see that we're nesting levels. We're beginning a transaction. We'll get the inside, and then I'm going to roll things back and get everything at that side. So what happens is when you have a nested transaction, when you're closing out of it, everything has to be at the same level. And what I mean by that, outside transaction for my session is 0, 0. As soon as I create my dynamic statement using SP execute SQL, I'm nested level 2. What it means is by the time I'm done with my dynamic SQL statement, I need to be back at the transaction level, the same that I was when I started. Otherwise, it creates that error that we just saw. So when I began my transaction, I have 1. I have the nested level 2. What needed to happen is I needed to close all the inside transactions, get that back to transaction level 1 or transaction level 0 before I closed out to make sure everything was set. Essentially, it's if you're going to do a transaction starting from within your dynamic SQL statement, close your transaction before you finish your dynamic SQL statement. You don't want to leave that open, leave a transaction hanging open. But because it's a nested transaction, you're going to get errors if you don't. It's kind of complicated to explain, but we have a similar thing if we deal with things like exec SQL 2. We still get that same error for the next transaction, but we also see that when we do that nest level, exec SQL is just 1. I think because it's SP execute SQL, it's a store procedure, that bumps it up 1, and then your dynamic SQL statement is where it bumps into nest level 2. So it's a little weird, it's a little funky, but the moral of the story is always close your transactions. Make sure you handle those, even if if you create it inside dynamic SQL, end it inside dynamic SQL. But also remember anything you do within that dynamic SQL is affected by the transactions on either side of it. Any questions about that? I know it's a little funky to describe. All right. I'm just going to show you this briefly, just to show you what the syntax looks like. This is if we're going to use that third way of writing dynamic SQL. I'm going to leave it for you. It's up on my GitHub so you can play with it yourself. But a simple way to run something and check against all your database, SPM is for each DB. You're passing it a question mark, and it's going to know to fill that in for each database that you're running things for. And so this is how you can run everything against everything. I almost never use it. I almost always use something like here, which is using the cursor to scroll through everything that I need to do. But this is an option that's available. I'm going to move on to delayed parsing because that's a little more interesting. If my machine will let me. And I'm not even showing the right results. I'm having SQL Server Management Studio does not like me this evening. I apologize. So I'm going to switch over quickly. This is why I have things like Azure Data Studio. And see if this will be nicer. I'm not sure what's going on with the things, but I am going to switch over. My apologies. All right. So let's talk delayed parsing. And so this is where we're saying we wanted to deal with things like we have an upgrade script, and there are things we can do or can't do in our upgrade. Things like create a schema. I've already upgraded this database. I can't run create schema like this because if I do, it's going to create an error. It needs to be the first thing in a batch. You can't just say if exists. Creating a table. This was the example I used. You saw in my slide deck. I'm going to add create a table with this column. My second release, I drop the column. If I were to run this whole script as is, that would create issues. And then we have an issue where I created a key constraint and I didn't name it, and I want to rename it. Well, I don't know what that name is because it comes with that funky thing. But if I use dynamic SQL, I can do different things where, as you kind of saw on my first demo, if I did an estimated query plan, it just said, okay, you're just going to run SP execute SQL. And it's not going to say, oh, you're going to create schema. More importantly, we also saw that the behavior of this is its own separate batch. So I can say if not exist schema, do the dynamic SQL. It's not going to create a problem because create schema is not running in the context of if exist or if not exist. It's running in its own context, but I've already done the check to see if I should run it at all. So if I ran this, because I've run this before, this isn't going to create any errors, but you can see I can use a little more dynamic SQL to say, hey, run this if these conditions exist. If not, I don't want you to parse it and create any errors. So it allows you to handle those sort of situations where you've ran a script, you've already run a script, and you know you have to run it the same exact script as is against another database. This is a technique I did several jobs ago where I had the same upgrade script. It didn't matter where I started, that same script was going to be run all the way through. So regardless of where you started, that end was going to be the same. So I honestly had to test often, make changes to turn things into dynamic SQL so the next time it ran, it wasn't going to create problems when I had to do those sort of checks. I'm going to move on to error handling. So this is one where you can do error handling with dynamic SQL. In fact, some of the problems that I ran into using dynamic SQL and error handling actually inspired me to write this session and put this together as well. I have some blog posts in my resources that you'll be able to look back and kind of understand a little bit more of the problems that we were seeing. So I'm going to go ahead and connect, and we're going to use my auto dealership demo, and we're going to take a look at some of this stuff. First, I'm going to make sure my person temp table doesn't exist. Let me see if I can make this a little larger. Now what I'm going to do is I'm going to test around with errors. I'm going to use Open Row Set. Open Row Set and Dynamic SQL was a lot of fun, and I learned a lot. Some of the stuff I'm showing you is what I learned from it. So I'm going to do an Open Row Set to a server that exists, the one that I'm working on, and I'm going to do a select just to show you how that looks. And we've got a basic select statement, and I'm selecting from a different database, superheroes. But what would happen if I connected to a server that didn't exist? Let's say my server was called Chihuahua, which is the type of dog that we have. And unfortunately, it takes a couple of bit to run because it takes 30 seconds for Open Row Set to come give me an error. Unfortunately, this is a little bit longer because we got to wait for things to error out. It gets a little bit awkward as we wait. And we can see that it has an error. Can we handle this nicely? We can. So to do that, we can do things like begin try statements. So I'm creating my statement, beginning try, creating my select, my variable, executing, adding a catch. We can run. Unfortunately, it still takes 30 seconds, even though it doesn't remember that it doesn't exist. So we're trying yet again. So another couple 30 seconds. All right, got my error message, can't connect. All right, so now we can show that we can actually handle errors properly. Now let's do a little bit more. Let's take that data and add it to our dynamic SQL into a temp table. So I have my select statement. I'm going to insert into my temp table, and we're going to see if there's any errors. There should be, because I'm going to the server that doesn't exist. Now, this is the thing that gets really interesting with Open Rosette, and one of the reasons why I put this together. Depending on where your error is and what you're doing, you could get different errors. And there are some errors that this actually won't catch, and you need to look at the specifics of how Open Rosette begin the try catch and find out what those details are, because this is what tripped me up. I actually think my error was more I had a double hop situation, and I had to be very specific on how I put things together to figure out what error I was catching so I could catch it properly. So here we can say the name pipes provider couldn't catch it. Now I'm going to do something different. I'm going to try to create a different error. I'm going to drop my temp table, but I'm going to move the insert inside my dynamic SQL statement, because remember, it's all part of everything together. So if the temp table existed, I would be able to insert from here. Now let's see what sort of error I get. Because the temp table's gone, I don't have the server, I should get a couple different errors. Which one is it going to return? Named pipes. So it's first thing that it does, it figures out that my select statement doesn't work. This open row set is trying to figure that out first before it can do the temp table. All right, so the database exists, but the object doesn't. So is that what this one is? Oh, okay, this is a different, all right. So we know my local host exists. I'm going to select from person A or persona. And let's run that. I just got a whole big error. Let's try the, oh, that's why. Let's try this one again. There we go. That one was much quicker. So it figured out quickly that because the server existed, it could figure out quickly that the table didn't. Next one where the table definition didn't match. So I'm dropping it, recreating it, getting the number of supplies different. What happens if that insert is inside that select statement? So there are different things that you're going to want to try as you're catching issues. And it depends on where you are as to which error message you're going to get. This is one where I still need to fine tune some of my different parameters differently so we can see some of those things. Like I said, my blog post really goes into details of the problems that I ran into, but being able to move that temp table with my select statement for that dynamic SQL actually allowed me to catch the error from my open row set much better because of what I was seeing or what I could catch or what I couldn't catch. But the combination of the two, you're going to want to, as you do error handling and figure out the different errors that you could get from dynamic SQL, you'll want to create your statement so you can really capture what it is. But the most important thing to know is you can capture that information. So let's see, my insert person, I think is now the 3. So let's do a quick, make sure that I'm doing this right. First person, first name. I just made this change earlier today. So let me make sure this is correct. So now let's try to do this. Actually, I wanted that down here. But the last thing I really wanted to show you is really this one down here, this cursor, where I want to create my temp table. And I want to do a select through everything that I have, make sure that I can handle what I can and not process what I can by getting that information, but handle the errors appropriately. Because this is one of the things that I had to do is I was going through a whole bunch of things and the server may or may not have existed, or I could or couldn't connect to it. So my problem was I needed to collect the data from the tables I could and just note the ones that I couldn't, handle those errors properly. So I really wanted to show that you can do that. For example, I can catch an error saying the Chihuahua server doesn't exist. At the same time, I can still say, well, my local instance did exist, and I can still collect that pieces of information. So I can put it all together, handle what I need to, move on from what I couldn't, and still record all the information along the way. So that's one of the things I wanted to show you with that. Any questions yet? Are y'all following along okay?
Yep.
All right. So now let's go to the fun one, and let's go into our our catch-all procs. So we've got two sets of store procedures here. I'm going to go ahead and run those. One of them is with our explicit values. This is our initial store procedure. And we have a whole bunch of default values, and these are what the default values are. I took that version and I created a dynamic SQL statement, and I'm passing in the same parameters. But what I do on the inside is I change it just a little bit. Let me run these two together. And while those are running, let me jump over and show you what those look like. This is the original stored proc, and this is your kitchen sink query, where I've got all the inner joins. A lot of times in production, you're going to see a lot of these, not only inner joins, you're going to see a ton of outer joins as well. And we know how expensive those can be, especially when you have these sort of where clause where the value is equal or it's null, parameter's null. And then you have stuff in here where the values have to be between these. And then the values have to be between these. And then you have to figure out that some of these are null fields and some of these aren't null fields. And you have to figure out which ones you care about being null or not being null, or does that make a difference? So what I did is I ended up taking that, and here's the version that I created for a dynamic SQL. The first thing that I did is I added this parameter at debug. This has been, I feel like it's a simple thing, but it's one of the smartest things I've done when I've done store procedures to handle things like this. And this is a hidden one. So I've set a default value. So if my application were to run this, it doesn't have to know it exists. It doesn't pass it in because we don't want it on debug when we run for production. We want debug to be one when we test it or as we develop it. And I'll show you why. First thing that I'm doing is I've got my variable, my nvarchar max, because who knows how long my final statement's going to be. And then I'm creating my parameter definitions. And what I'm doing is I'm just taking everything here and I'm making a parameter list. So this is going to be easier to read, or actually not to read, but to pass it into my final SP execute SQL. I've got my parameter list all set up. I just plop it in, one parameter, done. Then I'm going to create my statement. One thing I recommend, I've been bad about doing this, but if you're doing a store procedure, I recommend not the first line, but within somewhere inside that statement that's quick to easy to find, putting a comment like this with not the double dashes, but actually use this syntax for your comments and say where you're getting the data from. Get what the name of your stored proc is. And the reason why is when we put the statement together, you'll be able to see this and know where it came from. And again, let me show you that in a little bit. But now I can put the basis of my select statement together. So I have inner joins because, well, my original statement had inner joins. But if I had left joins, I can use the parameters being passed in to say, hey, do I need to join from this table? Or am I grabbing any from this table? Nope. And I can exclude it from my statement, and I don't even have to call that table. But I also do things like where 1 equals 1 so I can make things easier to add on later. But now I can sit there and add my logic to say, case if, if my value is either null or an empty string, don't do anything. If it has a value, then I like formatting, putting a return string in, and then I can add my statement. Then I can make things match. And then I can create my where clause based on the data that I actually need to check and to see if it's in my where clause. So I'm only searching on what I need to. What this does is it creates a very different statement, but it's selecting what I actually need to select. And I do that all the way through the end. Sometimes it comes up a little differently, but again, this is where you have to really know what you're looking for and making sure that you're handling the changes properly. And if I'm debugging, here's where that parameter comes into play. I can do things like print my parameter list, make sure everything's there. And then I can print my SQL statement. With a print, it will have a limit to 4,000 characters. So if you're doing a super long statement, you'll want to know and you'll want to handle that appropriately. Select can be, again, you have limits based on how you're getting that statement out. It's a fun one to figure out, but again, you can do things to get your statement to see if you're printing everything out properly. And then at the end, you can execute your statement. Sometimes if I've done debug, I just want to print the statement and not execute it. It depends on what you're trying to do. But this debug right here, if you're doing dynamic SQL in a stored procedure, I highly, highly, highly recommend doing something like this so you can really see what your statement is, especially as you're putting it together and especially as you're troubleshooting it, because you need to see what statement looks like to make sure you're executing it properly. Are you putting everything together? Is everything coming together the way you want it? And then you can take what's printed and then you can make sure you're fine tuning and you're performance tuning the statement that's being generated to really make sure that that's actually what you wanted to execute and that it's executing in a good performing manner. Now, if we go back to my query here, we can see our results. And actually, I should have done this showing the query plan. That one didn't take very long, so I should be able to get those information. So we have two things of query plan. Let's see if this one, it's a little hard to read, but I think we can probably make it out. If I hover over, we can tooltip, we can see that this is the first one. We can see the inner joins, but we can see our where clause where everything is there as we need it. And let me zoom out. And now we can scroll down to our second one. Again, we can now see the select statement that's created, but it's also, we have our print. So we now see that comment that I made. And now we can kind of see a little bit more about what's being passed in. This one, because it's the same thing we had before, it's going to look a lot like the initial query. Now this one, did I run with the debug? I didn't, but let's do a different one, a simple one with that debug so we can see what that looks like. Pull this up. We can see our messages. We see our query plan. We can see that it comes up here. If I zoom in a little, hover over again, we can see that we only have that color name equals the color name. So we can now see that the statement is slightly different. But as that's hard to read, I can now go to my messages, and now we can see the statement all out. So we can see what we actually executed as part of the problem, or as part of our figuring out, did we execute what we wanted it to actually execute? And when we do comparisons, we can also I wanted to originally show some of the differences between the stats that were done based on the way that we're creating our statements. But I'm going to have these available so you can play a little more with that. I know there's a lot of, I want to keep a watch on the timing here. So, but again, I've had to do stuff like this dynamic statement for store procedures and really create those. One company right before I left, I was working on one single catch-all statement that was being generated from the ORM, the Hibernate, that put together this awful, awful query. It took me months. I probably spent 4 or 5 months working on this one query alone, turning it into a dynamic SQL statement. And each along the way, the different parameters, the common combination of parameters that were being passed in, testing for each of those, performance tuning. But what I was performance tuning was this statement here, this one that got created. Because when we create dynamic SQL, especially to deal with these catch-all procs and really making sure we're tuning, this is what we're going to tune. I mean, we want to make sure everything that we're using to put that statement together is tuned as well. But our final query, this is what we're going to tune. But remember how I was showing earlier that dynamic SQL is kind of, while it's part of the same session, it's not really part of the same batch. We can kind of, this is why I recommend doing something like this. I'm personally bad about this, but it is a good recommendation, and I want other people to be better than what I am. I want to show you what happens when we look at Query Store, and we will look at our queries later. So I'm going to connect to the auto dealership demo, and then I'm going to do a select statement for my Query Store, and I'm going to look for inventory, and hopefully I've got stuff that pops up. So we see stuff here. We see object name, and we can see that's original store procedure in our object name. And as we go through, that popped up, and this is sorted by date. So we're not seeing the query that we ran, but we are, because if I look at SQL text, this is the proc that I just ran. And I can see it because this is why I put the comment in there. I want us to know that it's there. I want to know where it's coming from because it's not connected to my object. So I don't know that it's part of the stored procedure. It's came from the stored proc, but because it's within that weird context of the dynamic SQL, it's not actually connected. The other way that you're going to want to use this is you can use extended events. So that way you can kind of do the step through, see everything that's put together. But again, it's one of those things that you're going to have to figure out, how am I finding this later so I can troubleshoot it? Or is this the query that's creating problems? I have this random query. Where is it coming from? It's coming from a stored proc. Put that proc somewhere where you can find it. I don't like putting it before the select because it's a comment. So sometimes that comment gets ignored and it's not added as part of the statement. Putting it somewhere where it's part of the statement, we're going to find it. Hopefully it doesn't take too much text. For some reason, this comment is super long, but you'll want to figure that out as you're putting it together. But it's another really handy tip so you can figure out what you're doing. You can troubleshoot it later. You can find it in Query Store. You'll see it when you do extended events, but again, you'll see a part as the entire statements. It won't be connected to your object. It'll be around there. You'll filter through the session ID and you can see it there. Any questions about what I've shown you so far?
And in the chat.
All right. Well, with that, I'm going to say all of these demos are up on my GitHub, and I'll give you the connection to that later. I think I have a couple fixes that I will add as well. But you'll be able to take these, you'll be able to play with these. But the important thing that I really want you to drive home with dynamic SQL is you can be smart about how you do it, but it has a lot of weird little quirks in the way it works that you really want to be aware of when you put it all together. So with that, let's think about some of the tips and tricks we've just talked about. Add debug to your procs, to your store procedures. It is a great way for, as you're working on things, to figure out, what did I put together? Is that what I wanted to put together? Or it's creating a problem. Let me figure out how to troubleshoot what just put together. Validate your parameters. You want to make sure that what you're passing in and however you're creating dynamic SQL, you really want to make sure it's only what you are expecting it to be. You want to make sure that no one can put other things in your parameters that could do bad things gets in there. That's why you want quote name for all your objects. It's really hard to put SQL injection for your object names. If you're using quote name, it will think it's there. And hey, you get to see what they tried to squeeze in there that you didn't want done. And then you can figure out how can you prevent that in the future. You can have error handling with dynamic SQL. It's after it parses. So if your dynamic SQL isn't parsed properly, debug will hopefully figure that out for you. Error handling will help you figure out all the other errors. Make sure you're using it. You can, it's very helpful. Put it in there. A lot of things where dynamic SQL gets into performance tuning. When you start tuning, it's the statement that you've created. Dynamic SQL is how you're putting it all together. Performance tuning is on what you put together. You're just creating different versions of those SQL statements to run. So when you think of performance tuning, that's where you're really going to focus on. I had a lot of resources as I put it together. I have a bunch of blog posts, which I think are really helpful, and I want to pass those to you. I mentioned Tara Kaiser talked about exec versus SP execute SQL. Tim Ford, Eitan Blumen, both of those refer to the Aaron Bertrand, making a more reliable and flexible MS for each DB. So if you find that you have something that you're constantly running on all databases in an instance, this may be something useful. I know there are probably PowerShell commands that you could do instead, but if you have to rely on old-fashioned dynamic SQL, here are options for you. I mentioned Erlan's blog. He has such in-depth error handling. It's really astonishing in a fabulous way. But these are the two that I use to find that issue with the transactions and the nested transaction levels that we have with dynamic SQL for those errors. Kenneth Fisher, he also has a session on demystifying dynamic SQL. So I recommend that if you wanted an additional resource to kind of reinforce things. We both talk about things in different ways, but I really liked some of what he talked about as well. So I'm going to recommend that to you if you want to learn more. I mentioned I had two blog posts that kind of inspired me to put this together because I was dealing with open row set and error handling and sessions and execution and all sorts of fun. So these two blog posts together are really what inspired me to put this session together. And I hope that you learned a lot from it as well, and not the hard way like I did. And I also included the Microsoft documentation for SP Execute SQL. So it has that little bit of information about the syntax as a reminder, because I always need the reminder about how to do the parameters. So with that, are there any other questions or comments? Hopefully you found this useful or even interesting.
So is this presentation, are you going to put this in the GitHub or because I know you probably had
Yes,
some links in there.
it is in the
People can
GitHub.
use them. Okay.
It's already in the GitHub. I probably have a couple tweaks that I need to upload, but for the most part, it is there. If you don't see any things updated after today or by the end of the weekend, you have my
Perfect.
contact information. Ping me and say, "Hey, Deborah, did you have some changes you wanted to upload?" And I'll be like, "Yes." But again, you can find it from my GitHub. The easy way to remember is I'm Deb with the DBA. That's also my blog. And I'm DG Melkin on all the socials. So you can find me there as well if you have further questions. But hopefully you found this interesting and this was kind of what you were looking for. Hopefully, I know, Christy, you said you had some issues with dynamic SQL in the past.
Beast that I have to conquer here soon. But it's funny because in your presentation you were talking about the MS for each database, for each DB type thing, and it made me think like I actually use today two T-SQL things that I have put in, like every person that does DBA stuff for any length of time has a little toolbox they carry with them from company to company.
Yep.
And I pulled it up during your presentation because I was like, I used that today. And one was a date from 2011, and one was a date from, let me see what the date is. And it's so funny because it uses dynamic SQL, but these things have worked for me flawlessly 2011, like all these years. So I just still on servers, they still 2011 one. Oh, are they both 2011? I don't think so. No, one's 2007.
Yeah.
Simon Fasser had created like a security script to pull the security out. And like I
Yeah.
used it. I shouldn't be telling on myself for having a
Yeah.
toolbox from way back then because it was new then. But
Well,
it still
actually,
worked.
dynamic SQL has been around for a long time. I
Yeah.
try to remember when, like the exact statement since I can remember. SP execute SQL. I want to say in 2005, but I don't know why. But that one's been around for a while as well. So dynamic SQL isn't anything new. It's
Yeah.
just, it has, everybody's like, oh, dynamic SQL's horrible. It's the worst thing. And I'm like, it can
No,
be, but I've had to use it so often.
that's my point, right? Is
It's,
that it's the importance is so monumental because I have scripts that, I borrowed years years ago that still work flawlessly. And once you do use it for the right reason, I mean, it's beautiful. It's funny because the script that I'm looking at from 2007 literally says, I put a little comment in that says this script was originally designed for SQL 2000, but works just as well in 2005. So, and I used it today on a 2019 server. So
yeah.
yeah,
The good news is it
important
has,
stuff, folks.
yeah. I will say that's you kind of bring up the point. It's been around forever and it has a bad reputation because of the SQL injection, but once you kind of those nuances, like I feel like I spent a lot of time on that first demo with all the different little nuances, because in some ways those are the stuff we don't think about.
Yeah,
Like we use it, but we don't think about those and like, oh, we can really take advantage of all of that stuff.
yeah,
So
super important stuff that has a you know, it's the misunderstood child.
yes. I mean, it's
That's what
still
was
a
that.
problem, but it's
Yeah,
misunderstood.
yeah, yeah. It still can be really beneficial because, like today, I just yanked all the security from that were on a decommissioning a server that I could pull into there. Say, oh, save that for later if I ever need it. So good stuff.
Yeah.
Yeah, love it.
All right.
Thank you. I do have to call you out and say at the beginning of your slide, you also did not mention your mad karaoke skills. So wanted
Well,
to
I
put
kind
that
of
out there.
covered that with the I sing in a
Yeah.
choir, I do bluegrass. I assumes
I
that there's a singer karaoke skills in there somewhere. So,
love it.
you
I
know,
love it.
the important stuff about me.
That's right. That's right. Well, we appreciate you so much for coming today and some great information. If I am going to, I got a little bit late on my last ones, but I will get this one up in the next few days on YouTube and then send out a blast to everybody to let you know it's there in case you got distracted or weren't able to attend or anything else. You can, or like me, I have to look at a video over and over and over to get certain parts that I need. So should be up. And again, thank you so much, Deborah. We really appreciate it.
Well, thank you so much for coming and thanks so much for having me. Again, I love talking about all of this stuff. So hopefully you found it useful as well.
Absolutely. Absolutely. Thank you. And we'll chat with you later.
All right. Have a good
Thanks
night,
all.
y'all.
Thanks. Bye.